Hello everyone, this is Mehru and today I'm going to present a short summary of our work on robust path planning and control for polygonal environment via linear programming. In this work, we design a set of output feedback controller on a cell decomposition environment which is robust to the deformation of the environment. We synthesize the controller over the entire set rather than a single point, and we ensure the safety and stability by defining the control barrier function and control Lyapunov function. We find our controller by solving the min-max optimization problem via linear programming. Assume we have a polygonal environment. We decompose it to the set of convex cells with a control system for each cell. For every cell, we define a barrier function as a set of linear equations of the wall. Vector z is the norm of the exit face which we want to pass through, and xe is a point on the exit face. We define the Lyapunov function as a function of vector z and xe, and the Lyapunov function measures the distance between the positions of the robot to the exit face up to a constant. We want to satisfy the safety constraints by control barrier function and stability constraints by the control Lyapunov function. We assume we have a set of points in the environment which we know their positions and their positions are fixed, and we assume the agent can measure the relative displacement between its positions and the landmarks. We define a controller that feedbacks the linear combinations of the displacement measurements, and we aim to find a control gain which is k. So we want to find a controller gain and satisfies the CBF constraints and CLF constraints for every point in the cell. So to do so, we form a min-max optimization problem, and we have the CBF constraints and CLF constraints in form of maximization problem. We convert the min-max optimization problem to the minimization problem by forming a dual of the CBF and CLF constraints. By solving this minimization problem, we can find a robust controller. Here we have the polygonal environment. We decompose it to the number of cells, and then we find the controller which derives the agent from different start points to reward the goals while satisfying the CBF constraints and CLF constraints. Then we deform the environment significantly, and using the same controller. Without replanning, we can reach the goals starting from the start points. To conclude, we propose a novel approach to design an output feedback controller on the cell decomposition system. The controller depends on the relative displacement measurements, and we find our controller by solving the min-max optimization problem via linear programming. The controller is robust to the deformation of the environment, and we validate our approach on numerical examples. Thanks for listening to my presentation.